In this section, we're going to talk about multiple linear regression. We're going to define the model assumptions and learn how to fit the multiple linear regression model. And lastly, we're going to talk about variable selection. So when we talk about the assumption for the multiple linear regression model, we're considering the relationship between at least two independent variables and the dependent variables. There are four assumptions we have to know before we build the model. First is the linear relationship between the dependent variable and independent variable. So we have to make sure that the multiple linear regression has a linear relationship between the dependent variable and each of the independent variables. The best way to check the linear relationship is to create a scatter plot, then visually inspect the scatter plot for linearity. If the relationship displayed in the scatter plot is not linear, then we need to run the nonlinear regression or transform the data using statistical software such as SPSS. The second assumption is the independent variable has to be not highly correlated with each other. So the data should not show multi-collinearity when occurs the independent variable are highly correlated. So the independent variable, if it shows a collinearity, then there will be a problem figuring out the specific variable that contributes to the variance in the dependent variable. So we should not allow that happen, and we need to make sure that the independent variable are not highly correlated to each other. The third assumption is the variance of residual has to be constant. So in multiple linear regression, we assume that the amount of errors in residual is similar at each point of the linear model. When we analyze the data, we should plot the standardized residual against the predicted value to determine the points are distributed fairly across the value of independent variables. To test this assumption, the data can be plotted on a scatter plot or using statistical software to produce the scatter plot that include the entire model. And the last assumption is the independence of observations. So the model assumes that observations should be independent of one another. Simply put, the model assumes that the value of residual are independent. And to test this, we can definitely use Durbin-Watson statistic. So if you use the SPSS and try to calculate the statistics, right? If the value shows between 0 and 2, it shows positive autocorrelation, and if it's the value is from 2 to 4, it shows negative autocorrelation. The middle point, such that a value of 2 shows that there is no autocorrelation. So it's good to see that there's no autocorrelation. It means the data emit the assumption that there is independence of observations. One way to test the relationship between the x variable and y variable is to test for normality, right? So if you want to see the relationship between your dependent variable and the independent variable, you can plot the two variables on the scatter plot, and you get the QQ plot here. If it forms a straight line, right? It's definitely normal. Or the other popular way is that you can plot a histogram, right? So if it forms a bell curve, that means it's also normal distribution. So it does have the linear relationship. Let's revisit the linear function. So the linear function for the simple linear regression is that we only had like one x variable, right, which is x1. And that was the only variable as the independent variable, right? But for the multiple linear regression, we have more than one independent variables, right? So we have to have at least two or more, right? So to build this multiple linear regression. So if you look at the linear function, so the y is going to be the beta 0 plus beta 1 multiplied by x1 plus beta 2 multiplied by x2 plus beta 3 uh, and times x3 and multiply by the arrow term if you have only three independent variable. Of course, if you have more independent variable, then you have more um, access, right? So basically, the idea is still the same. You try to get the best fit straight line, and you try to minimize the residual or the standard errors. So it's just a little bit more complicated than the simple linear regression, but the idea is very similar, right? Variable selection in linear regression refers to the process of choosing which independent variable is to include in the regression model. In the linear regression model, right? So the goal is to find the best combination of variables that can accurately predict the dependent variable, right? So there's three popular variable selection method. So first is forward selection, and then we have backward selection, and then the last we have stepwise regression. So for the forward selection, we begin with the assumption that there's no regressors in the model. And then we check the model with all possible regressors and add them individually. And the last is we add the regressor that most change your criterion in the correct direction. And then we go back to checking the model with all possible regressor and adding them individually again. And then if none of the regressor have the positive effect on your criterion, then we stop the regressor you have, and that's your final model. So the backward elimination method is another one that people tend to use a lot. So it starts with all the candidate regressor in the model, right? And then it dropped a predictor that improved your selection criterions at the least. And then you continue until there's no predictor that can be dropped, and the result in an improve of your selection criterion, and the remaining predictor defines your final model, right? And then last is the stepwise regression, right? So stepwise regression is another method for the variable selection. The general stepwise regression techniques are usually a combination of backward elimination and forward elimination. So those three are most popular variable selection techniques that you can use. Of course, you don't have to know exactly how it works. Actually, in the SPSS software, it does it for you. So you can use either techniques, try to see what model that they select for you. In the next section, we will look at the output of the model and try to evaluate the model and see which model is the best model and which model is not doing well. there are some evaluation techniques that we're going to learn. So we'll talk about that in the next section.